Hello, this is Group Beta. My name is Amritpal Singh and my student number is 99134503.
Hello, my name is Sahil Devgun and my student ID is 99134742
Hi, my name is Asham Singh. My student ID is 99134528.
Chalo.
My name is yograj bajwa and my student number is 9913280066 and our lab time is Wednesday from 2 o'clock to 4 o'clock.
Today we are performing the weld testing. Welding. What is welding? Onto these two parts. Welding is a process in which we join two metal samples with the help of heat and some fillet material. As we can see in this material, we use fillet material to join two samples. This is the high carbon and this is the low carbon steel. We join it with the help of welding, and we're going to perform several tests to analyze the microstructure and hardness of these two samples, and what is the difference between what the difference came in these two samples after welding, and in the weld zone in the whole part, what is the main difference, and what are the microstructures in the weld and other parts of the welding. First we're gonna take the hardness reading. There are two hardness scales. This is Rockwell hardness C scale and this one is Rockwell hardness B scale. Both have their different properties. We can what Rockwell hardness C scale is for the harder material which have the hardness more than 20 HRC, and Rockwell hardness for this is a B scale. This is used for the softer materials like tin, lead. This is the scale, Rockwell hardness B scale. We can see the dial here. Here is a mass, this is a mass which is applied on this tip. This is the tip of the hardness scale. This is a iron tip, a steel tip. We can see that when we apply the load, this tip goes into the metal sample, and then it is in the forward direction right now. So that means the load is not applied. When we do it into the backward direction, it goes to the backward direction and more load is applied on the sample, and then this needle starts moving into the direction. After that, when it stops, we're gonna again bring it to the forward direction, and in this way we're gonna get the value for the hardness B scale. Same is the procedure for the hardness C scale. Here is the difference is that we can make the scale to the zero with the help of this analog. As we can see, I move this circle, the analog also moves. As I move this, we can see that we can set the needle to the zero in this way. As I move this one, on the other in the HRC, it is in the different way. We can set needle to the zero with the help of this small, but as we can say, knot or something like that. We can, when we move, the analog also moves, and we can set needle to the zero, and then we can apply the load on the metal sample. As we can see, there are different knobs here. This one is for the cylindrical part. If we have any cylindrical part, we can keep it here, and this will not move. So first of all, we take the hardness scale. Always test the material first on the C scale, because if the material is harder and we go to the B scale, it can break the tip of that B scale and whole scale could be ruined. So that's why I first take the reading on here. I'm gonna settle down the metal here. Pause kar de. Now I am settling down the sample here. We can see that the tip is now on the touching with the sample. Now we're gonna make this black needle to the black dot, like in this way. This is the right. Now make the needle to the zero. To reduce the parallax error, we're gonna take it from the front so that we can't get any parallax error. Now apply the load just with the tip. Don't apply any extra force, so the reading can be exaggerated. As we can see that the needle is stopped here, so it's in the backward position right now. We're going to make it from the forward direction. Here it is. So we got the reading here. there are two scales, HRB, this is for the HRB scale, and this is for the C scale. We got the 29 reading for this one. In this way, we're gonna perform the whole experiment and whole hard rest readings. Now to remove this, just take care of this that the load is in the forward direction. Now just simply make it down. In this way, we're gonna perform the Rockwell hardness testing in the both way, on the both scales. First, always take the first C scale because tip can be broken and the whole scale could be really takes more time.
So now we are on the grinding part. We have to grind the metal. So to see some scratches on it, first turn on the water flow and then put part on at 45 degrees on this belt and rub in this way. Here. So to make these scratches small, rub on this belt. These both have different roughness. So now the grinding is done and we make the lashes less, and now it's time to polish the part on this machine. So now we are on the polishing machine. We have to polish the part. Start the machine and pour some aluminium oxide on it. This helps the part more. This can make the part more smoother and shinier. So we have to apply this, and if we found it dry, we can pour some water on it to make it wet. So now we have to polish our part. So we have to start polishing. It can be done by this way. We have to take the part to the middle of this plate and get it this way. So now we have to wipe it with the distilled water so that we can clean the surface. Now we have to use this tissue to clean this. We have to just put it on the part. We don't have to touch it and let it be to get it wet.
Yes, now we done the polishing part. So now we will move on the etching part. Here is the part which is shiny and crystal. So we move on this part. First we will use the nitric acid, which contain the 2% of nitric acid and 98% of methanol. So now we poured some drops of nitric acid on our sample, as you can see on it. We should only keep this acid only for 45 seconds, because if we keep less than 45 seconds, we can't see the microstructure in the microorganism. And 45 seconds, we can't obtain the proper structure of carbon. It's gonna be burnt, and we can't see the grain size on the microscope. Now we're gonna clean up with the distilled water, because we can't use the tap water for this. Now we've done the cleaning. Now we should use the tissue paper for this. We have to dry it gently, because if we don't want to do the fingerprints on it. Now I place the tissue paper on the material to soak the whole water, and then we can get the proper material, fine material with lustrous and proper shining. Now you all can see after the etching, the material is so fine, so we can go with the microstructure now.
Now we're going to put our sample on the microscope. This microscope contains the islands of 10x, and as we can see, this microscope is Olympus G41, and this thing is to zoom in and zoom out. As we can see, as I rotate this one, it is zooming in, and and these two wheels are to move the sample. This one moves the sample forward and backward, and this moves the sample left and to right position. And now you're gonna see the microstructure of this sample.
Start.
And there we have 4 focus lenses. They have a focus capacity of 5x, 10x, 20x and 50x respectively, with the help of which we can see the pictures very clearly. Here's our cam with which and this is the PEX cam of microscope, which is connected to the eyepiece. With the help of this camera, we can see the pictures of our sample very clearly on the screen, as you can see. This is the microstructure of the part from the extreme left hand, and we can see the grain sizes are very bigger on the left side. And as I move towards the valve part here, and we can see the grain sizes are and as we move on the well part, center part, and we can observe that the grain sizes are very smaller than the extreme ends. And same with the left part here. And in this way we got the 5 captions of the sample from the different positions, and we analyzed that all the images.